Hey guys, Brian Lovett here, aka B-Love. Today I wanted to talk a little bit about some questions I've been getting on Twitter related to how I'm printing these coronavirus masks for doctors and hospitals. Now first, I apologize if you can hear my 3D printer printing in the background. Normally I would shut that off during a video, but in this case, I don't want to take any time to shut it off when it could be printing masks that'll help somebody out in the hospitals. So let's jump right into it. So first, let's start with materials and what I've been using. So originally, when I started printing these, I was printing the masks in 100% PETG. PETG is a material that is used a lot in like water bottles, for example. And so I was printing them out of PETG, but the problem is that PETG, while it's flexible and durable and all of the things you would hope it to be, it's still really rough on the skin. Like if you have a PETG mask sitting on your skin for 8 hours or 12 hours a day, you're gonna run into problems. It's gonna be chafing and cutting and scratching you. And so the feedback I got from that was that it wasn't very comfortable to use for long periods of time during a shift. So obviously we want to help prevent that. We want to make this as comfortable and useful for our doctors as we can. So I kind of went to the next iteration, and what I did was I printed the first like 70-80% of the mask out of PETG, and then I transitioned it to TPU. And TPU, if you're not familiar with it, is a really flexible material. It's almost like rubber, and so you can use it to kind of make a gasket, and you can see how flexible it is here. And so what that does is it creates this kind of nice, comfortable layer that sits across your skin. And the other cool thing about it is, since it's flexible, you're not going to get that like chafing and scratching that you would have from having this on your skin for a full day. So the first thing I wanted to do is have these anchors out of mostly PETG. That's why I have the layer height where it switches to TPU so high, because I wanted these to be as strong as possible. The downside is that this bottom part that goes across your chin or around your chin is still PETG. And so what we did is we did a test and we printed a mask 100% out of TPU just to test the strength of those mounting points where the straps go. We actually found that that was really comfortable and that those mounting points in the TPU are still really strong. So for the next iteration, you can tell I dropped the TPU layer down quite a bit. So now you get a nice TPU layer all the way around the mask, and it's thicker around where the cheeks and the nose go. Because of that, the entire bottom mount is now out of TPU, but it's still super strong, and I don't think that's actually going to cause any long-term durability issues. So let's talk about the filament that I actually ended up going with that achieved this result. The first thing I want to do is I used PETG, which is what they use to make water bottles and a number of other things. And that's what I use for the base layers in all of these. You could also probably use PLA and then use PETG along with that, but I ended up using PETG just because it's flexible and really durable. It also has a higher melting point, which could be good in the case where they're going to have to take these and sterilize them in between uses. They're probably going to be using chemicals and other things that might damage PLA, but we know from being in the field that PETG holds up to that. So PETG is what you're going to want to use for the base layers, and then TPU is the material you're going to want to use for the rest. And TPU, again, is really flexible. You can see how much this stretches. It's almost like a rubber band. And so some printers have a difficult time working with this, but I'll tell you what I did. Anytime you get a new roll of any type of filament from a new company, you want to go and you want to print a temperature tower. You can see as the temperature goes up, the stringing in between the layers gets really bad. And you can also, if you look at it, you can see how the overhangs perform at different temperatures. You can see how the bridging performs at different temperatures. And what I found actually prints best and has the least stringing at about 220 to 225. The cool thing about that is I don't have a multi-material printer. I have a Prusa Mark IIIS with a single extruder. And even so, what I'm able to do is in Slicer, I can set my layer height for the material change. All I do in Slicer is I go down to, right here in the layers, and I set a color change. And what that does is as this prints, when it gets to this layer, the material in the printer gets unloaded and it asks me to load a different filament. The cool thing is that by printing the PETG at 225, that's the same temperature that I need to print my TPU at. And so I don't have to worry about changing any additional settings. They both print at the same temperature and the prints come out really good. Now, I have also printed multiple different designs for these masks. I of course have this style, which if you take this, it's actually 3 pieces. This piece pops inside of here. That's what you actually wrap the HEPA filter or whatever filter material you're using around. And then this piece snaps on the front like this. And between the two, sandwiched in between, is your layer, your filter layer. And this is nice. It's easy to take apart for a doctor. It's easy to clean, and that seems to work the best. The other design I tried to use was this one, where it's 2 pieces, and it prints the entire main structure, the part that holds the elastic that goes around your face. It prints that in the PETG, the primary material, and then separately you print this TPU. But the problem with that is you've still got to glue it on there. And so 2 things that are problematic with that. One, you're going to have to take the time to glue this. So you've got to have glue. That takes extra time. It's also a lot of hands-on involvement. These usually I just grab off the plate, the printer plate, and I get them right into a vacuum seal bag so that there's minimum time for them to get contaminated. But with these, you have to really get in there and handle them a lot. The other problem is whatever material you use to glue this, I actually used super glue, and well, I'll show you. Here's one that was super glued, and it still just comes right off. So I don't know what type of material would be used best to bond these together, but it's not worth taking the time to do it. The third problem I have with these is instead of having this just nice square piece, which if you have what they're doing is at the hospital, they're taking an N95 mask and they're just cutting squares out of them and placing that in here. And with this one, it's easier to breathe. It has 50% more surface area, which is nice, but it's also an odd shape. And so the doctors would have to cut this odd shaped filter out, and they're not going to get as many masks per N95 mask made out of that as they would with this design. So this is the one we're finally going with. It has the full wraparound TPU, it's made out of PETG, and it has this square opening. That seems to be the winner from the doctors that have tested it. So the other huge question, where can you actually get PETG, TPU, all that material right now at a decent price and shipped to you quickly? I went with Zyltech. No, they didn't pay me for this. They didn't give me discounts, nothing like that. I went online and I looked everywhere. I looked at Amazon first. Amazon has a bunch of shipping delays, and they're also out of most filaments because that's, I think, the first place people hit. I also looked at Matter Hackers and a couple others, and they're pretty much completely wiped out of PETG. Zyltech, I've never used them before previously, but they have tons of PETG, at least in stock as of a couple days ago, and their pricing was really good. I think 2.2 pound roll, a 1 kilogram roll was $22 at PETG, and it was $17 for TPU, which is the lowest TPU price I've ever seen. The other cool thing is I just use their regular ground shipping, their standard shipping. I didn't pay extra, and I was able to get these. I ordered them, I think, Sunday night, and I was able to get these by this morning, which is Wednesday, so just a couple days for shipping. Now, the last thing you want to do before you print any of these, before you undertake any of this, is head over to masksfordocs.com and see which hospitals are even accepting donations, which hospitals are in need, and also what designs they need. Some of them still just need the face shields. They don't want the masks. And some hospitals, like Northern Colorado, they're not accepting any 3D at-home printed parts at all. So check with your local hospitals. Like I said, I've been working with a couple local doctors. They're using these, and just that one hospital thinks that they're going to need about 100 of these. So I got enough filament to print out 500, so we should be more than covered there, but check with your local hospitals and anyone you can before you print them to make sure that they're going to be accepted and they're going to be useful. You don't want to take the time to print something that's not going to be used by an actual doctor and that's not going to help save some lives. So don't waste your time. Go to masksfordocs.com and you can figure out what's needed in your specific area. I'm going to drop links in the description for all this stuff. I'm going to drop a link for my 3MF files and my STLs. For this, again, I'm printing them on a Prusa Mark IIIS, but you can use those as a starting point for whatever printer you're using. And I use Prusa Slicer for the actual slicing of the models itself. I have been able to print 3 of these on each build plate. So I've got them oriented so that the 3 complete sets fit on each one. And that should be all you need. It prints in about 8.5 to 9 hours per 3 masks. So let me know if you can optimize that. If you come up with any settings that are better than mine, I would love to hear that. And drop me any questions or comments you have down below, and I'm happy to answer them. I'm happy to do another video like this if it comes down to it. But let's see where we can help out as a community. And thanks, guys. We'll talk soon. See ya.